Now we are going to get started with the research paper presentation. The paper that will be presented in contest session 1 are about environment and appropriate technology. All presenters must finish their presentation within 20 minutes, and we are going to hear judges' comment on the paper, also open to the floor, and also we will give you presenters to respond. Okay, first, 라밀리아 지드케이에바, 사오 술레이메노바, 아이젠 주스포바 from Al-Farabi, Kazakh University will present a paper. The title is The Freshwater Saving. Please welcome them with a warm round of applause.
Our project is Freshwater Saving. It was created in MDP Global Classroom, Kazakhstan. The main idea is rational use of drinking water by using alternative sources of water. Supervisor is Rafiz Abazov, professor of Columbia University. Team members you can see on slide.
The main purpose of our project is to consider different technologies for collecting rain and melt water in different countries. Here we can see the tasks. The first is to make a review of all existing technologies to collect melt and rain water. Second is to choose most appropriate technology for our region. And the third is to provide justification for all executive, for the executive group for further implementation in practice. Annual water consumption in Kazakhstan is about 20 to 30 cubic kilometers. And from year to year, this number is increasing. And here we can see two pie charts. The first pie chart represents the water use by sectors. And the majority of water goes for irrigation, as we can see from the pie chart. This is 66%. And almost the same situation is in the world. It is 70% of water going for irrigation needs and livestock. If we consider the water used by sources, it is, as we know, it's different sources, and almost 90% of water comes from surface water sources. Which in many cases is fresh water. And one of the problems of mankind now that we use the water, the fresh water, not for crucial points. For example, for drink, for cooking, and also for personal hygiene. But we use drinking water sometimes for just washing the cars maybe, and also watering the gardens and this stuff. One of the it means that we use it not so efficiently. And in order to reduce the consumption of drinking water, we consider the use of alternative sources such as rain and melt water for the needs of each household. And technology to collect melt and rainwater have been known since ancient times. For example, in Asia and Africa, they were widely used. And now they are widely used in both countries, developing and developed countries. And the main idea is to collect water from the surface and to collect it in special tanks. And nowadays, all technologies aimed at obtaining more pure water using different filters. Next slide, please. Here we can see the types of rainwater harvesting systems. So depending on the location of the tank, it can be underground and the surface. depending on the number of tanks, it can be complex, like 2 or more, and simple, just 1. And depending on the method of supplying water, it can be gravity, so like self-floating, and mechanical, using pumps. One of the bright example of water harvesting system is Eden project in the United Kingdom. This project is a chain of several glass houses consisting of 3 main biomes. Each of them, there are several different plants from different parts of the world. And under these biomes, we have 2 main tanks with total volume of 240 cubic meters. And one of the interesting things that since 2007 until 2008, when the harvesting system started to work, they have cut water consumption by 20%. And water from collecting water goes for 3 main purposes. The first is for irrigation of the plants. The second is to maintain the humidity in a certain level, and to supply the water for the rooms of the visitors, The nice example of using this technology is German permeable paving for roads. After rainfall, after the rainfall, the water goes through the paving and goes to special trays. And after this, it goes to special tanks. And this water usually we use it for watering the pavement and the roads. And also one of the interesting example is upside down umbrella. This is a unique example of design to collect water in, for example, especially in parks, in gardens. And this umbrella acts like a surface of water harvesting.
In our presented technologies, is really important to see the technological aspects. It consists of area of water harvesting, filters, storage tanks, and pipe system. Area of water harvesting, it can be free of harm components such as lead, copper, and in many cases it can be created from natural materials such as tile. Filters can be used as simple as complex. Storage tank can be also free of harm components, and the pipe system can be made from polypropylene. The tanks. If we consider tank, the main point that we need to consider the capacity of the tank. And we can find it by using this formula, which you can see on slide. It consists of roof surface, annual precipitation, and effectiveness ratio of water harvesting. The system number 1 is rain water harvesting technology with the using of surface tanks. This is technology very appropriate for a region with a medium precipitation, and after rainfalls, water going by roof to a special tray, and by pipe system it goes to tanks. It can be 1 or more. And also, if we wanted to low cost of this system, we can use the secondary material tank at this one. The system have advantages and disadvantages. Main advantages is that we can to change capacity of the tank by elongate the chain of tanks. And main disadvantages that in many cases the tanks can take a lot of place underground. Oh, sorry, on surface. The second system is rain and melt water collecting technology using underground tanks. This system more complex than in previous, and there we have two sources of water, is snow and rain. And of course, two surfaces, the yard and the roof. Yard can be installed under a special angle which supposed the floating water to the collector. Above collector, we install special net for collecting debris. And in this system, it's really important to have filters. The main advantages of this system is that we have a big capacity of collecting water, and the main disadvantage is that we need a special service, and also with this system not easy to operate. And also it will be better to install the system before the start foundation of the building. But in many cases we can install it in a already built houses, but the price of this system can be higher and not so appropriated for design of the yard, of course. Melt water collecting technology using water trap for water harvesting in artificial ponds. This is system more appropriated for maintain regions and with the medium and also with the high precipitation. After melting water going by traps and at least reach the pond. And this is the system very appropriated for our region because of in many regions in Kazakhstan we use a drainage system for irrigation. And the pond can be act like a source for water. The main advantages of this system is the big capacity of the water, and the main disadvantages that it's hard to operate and high cost. Handmade rainwater harvesting system. This system is simple and can be used like an addition system for previous mentioned systems. So it consists of main pipe, which made from polypropylene, and also to fuse bottles to this main pipe. The capacity of the bottles can be vary. The point is how to fuse these bottles to the pipe. We have two ways. We can order a special adapter from inventor of this system, and we also can use polypropylene coupling with internal thread. This is idea of our team, and we can use just using this coupling with internal thread to a main pipe. Economic feasibility of water collection system, of course, depends on many points. So the first one is the quantity and quality of water from different available from the other sources, which mean, for example, in Kazakhstan we have a different cost of water. In some region it's high, and in some region it's low. So it depends if the region have a high cost, it's more appropriated for using this technology. But in case if the cost of water is low, it's not so easy. Also, it depends on household size. Of course, choosing of one of the four systems, it depends on this point. Because if you have a big surface, you can harvest a lot of water. And if you have a not so big surface, you can collect, of course, a little amount of water. And also you can choose, for example, for a big capacity, for big surface, the system with the big capacity, such as, for example, the system with the underground tanks. The next point is climatic characteristic and the amount of precipitation. As I mentioned before, in formula where we mentioned the capacity of the tank, it's really important to know the climatic characteristic and the amount of precipitation, because from this point depends the capacity, the amount of harvesting water. In some region, it's not. We have no opportunity to install this system because of low precipitation, and of course budget. So complexity gradation of system. The less complex and less cost system is system with the bottles, of course, and the more complex system is the system with the surface tanks. More complex than these 2 system is the system number 3 with the artificial ponds and water traps. And the more complex, of course, with the higher cost, is the system number 2 with the underground tanks. So, thank you for attention.
Oh, thank you. Very excellent and succinct presentation. As a chair of judge panel today, I just would like to introduce our panels first. We have 8 panels, but the last panelist did not come yet. But the way we evaluate your presentation will be such as, immediately after the presentation of 15 to 20 minutes, I would like to assign one main discussant to present their views and remarks during 3 to 4 minutes, and to be followed by 3 remarks by the panelists on the evaluation committee. And then, if time allows, I would like to allow our audience to contribute at least 1 question from the floor. Then the presenters will have time to respond or answer the questions. That's the way we manage the panel today. So I'd like to invite the first main discussant for your presentation this morning, Mr. Istaq. All right, so go ahead.
Thank you very much, Chair. My name is Artemis Mesif. I'm from UNDP in Korea, and I would like to first of all say that I really liked the paper that was introduced by the 2 authors. The main reason for that is definitely its relevance. Central Asia is facing fierce competition for the fresh water. And a lot of authors write about the water crisis. And of course, when the leaders of a lot of Central Asian nations deal with the issues on how to divide the transboundary waters, it's great to see that the crisis also brings great opportunities. And the opportunity is that people like yourselves start exploring the issue of appropriate technology and start exploring how it's possible to adopt it. This work is going to become ever more relevant, especially now when the region is starting to face the consequences of the climate change. We have sometimes more water in the places where we don't need it. We have less water in the place where we need it, and the patterns are quite unpredictable. And this is why this issue of development of technology and its adaptation is going to become ever more relevant. I like the mapping that you conducted in your paper. My question is a question that I would ask to most of the authors writing about the appropriate technology. Very often we have good ideas related to water or any other issues, but the ideas are not being applied. And sometimes the factor behind their applicability is not purely technological and not purely economic feasibility, but it may be social, it may be it may be in a governance factor. For example, the units within the government responsible for adaptation of these technologies would not be interested in doing that. Or there might be some powerful stakeholders who prefer using the established status quo. Of course, I realize that it goes way beyond the scope of your original assignment, but I want to ask a question on what do you consider the main factors for adaptation of these technologies? Who should be responsible for their promotion in your country and elsewhere in the region, and how to make sure that these technologies are actually adopted? And if you are aware of any cases where it worked, it would be also interesting to know, not just in theory that you described really well, but in practice, how it's working and how it's making a difference for people.
Yes.
Thank you very much.
So the question is how to implement it in practice.
Yeah.
Okay.